Welcome to the philosophy section of Logic, Language and Information. In these 3 lessons, we're looking at connections between logic and philosophy. Now, in some of the application sections, we're going to look at the way that logical techniques can be applied to solve problems in different domains. Here, we're going to do something a bit different. We're going to start by looking at a philosophical issue at the foundations of our approach to logic, the assumption that there are just 2 truth values. We'll focus on one place where 2 truth values seem to make life very difficult for us, the problem of vagueness. Now, here are some sand dunes made up of billions upon billions upon billions of grains of sand. 1 billion grains of sand are more than enough to make a decent-sized heap of sand. But if you remove the grains of sand 1 grain at a time, eventually, if you have enough patience, you won't have a heap anymore. This 6 grains of sand, seen under an electron microscope, for example, don't make a heap. But a huge sand dune like this certainly does. Now, removing any 1 grain of sand isn't enough to convert a heap into a non-heap. But the difference between a heap made up of 1 billion grains and something that isn't a heap, say just those 6 grains of sand, is just made up of a very, very long series of removing single grains, one at a time. This is what we call the Sorites paradox, the paradox of the heap. The name comes from the Greek word soros, for heap. The vague concept of heap doesn't seem to fit easily with the idea that every statement is either true or false. Now, there doesn't seem to be a sharp borderline between the heaps and the non-heaps, but the idea that every statement is either true or false seems to impose a borderline on us. If you took a grain of sand from your heap, and each time when you did, you said, "That's a heap," then if every statement is either true or false, that statement that you make will flip from true to false at some stage. And that would be your borderline. But there doesn't seem to be a borderline like this out there in the real world. Now, this isn't just a matter of grains of sand and heaps. Colours, for example, also don't seem to provide sharp borderlines. The colours in a strip can shade subtly from red to yellow, where there's no sharp borderline between the red area and the rest of the strip. And the same goes for the transition out of childhood during our lifetime, or the transition into adulthood. In neither case does 1 day or 1 second make the difference between being an adult and not. The same goes for concepts like large and small, or fast and slow. Now, none of these concepts are defined in sharp ways. All of them seem to have borderline cases that aren't clearly in the category and aren't clearly out of the category. In each case, we have examples of what we call vagueness. And vagueness is just one of the issues that helps us examine the assumptions we've made in the 2-valued picture of logic. So let me give you an example of the Sorites paradox, and we'll examine it in more detail. Take a strip which shades evenly from red to yellow, and we'll divide it into patches so that it's divided up into enough pieces, say 10,000 will probably be enough, so that adjacent patches along the way look indistinguishable to you. So we'll have patch 1 at the leftmost end, patch 5,000 right in the middle, patch 10,000 at the rightmost end. Then for each of these numbers, for each of the patches, let the statement Ri for number I be the statement patch I looks red to you. So then the statement R1 is true because the leftmost patch is definitely red. It's at the red end of the strip. And statement R10,000 is false since the rightmost patch is definitely yellow and not red. And since each adjacent patch is indiscriminable by the naked eye, each statement of the form Ri implies Ri plus 1 is true. So if R1, then R2, if R2, then R3, or if R5000, then R5001. Each of these statements is true because if something is red, then anything that looks the same as it looks red too. The argument from the premises R1, if R1 then R2, if R2 then R3, etc., to if R9999 then R10,000, to the conclusion R10,000 is valid. It's an 9,999 step modus ponens argument. This is the problem. The problem is that given the Sorites argument from these premises to this conclusion, the premises of the argument all seem like they're true. The argument seems like it's valid, and the conclusion seems like it's false. These three things can't all be as they seem, since a valid argument with two premises doesn't have a false conclusion, its conclusion's got to be true. And this is the Sorites paradox. Now, there are four broad options that we could give in response. You could say that logic doesn't apply to vague expressions. The problem is ill-posed. The issue of validity and invalidity doesn't apply to vague concepts. That's one option that you could take. The next option is that logic does apply, but that the argument is not valid. That way, the premises could be true and the conclusion false. The next option is that logic does apply, the argument is valid, but not all of the premises are true. At least one of the premises is false. And to round out all of the options, the only thing left is that logic does apply, the argument is valid, the premises are all true, so the argument is sound, and it follows that the conclusion is true. Now, any response to the Sorites paradox fits into one of these four options. Now, the last option is desperate. If you agree with this, you agree that yellow is red, that tiny things are large, that one grain of sand makes a heap. This is to reject the use of vague concepts to draw distinctions at all. So we're not going to be exploring that option any further. The first option is also desperate. We reason with vague expressions all of the time, and some of these arguments look valid and others of them look invalid. Often we reason in ways that are nowhere near the difficult borderlines of vague concepts, and here logic clearly applies. So we're not going to pursue this option either. This leaves option 2 and option 3. Either logic applies, but the Sorites argument is not valid, or the argument is valid and not all of the premises are true. In the next lesson, we're going to explore option 2, because if the Sorites argument is invalid, this means that some of the assumptions we've made about validity are mistaken, because our standard account says that that's a valid argument. We're going to look at one prominent way of doing this, by admitting more truth values than simple truth and falsity. This leads us to fuzzy logic, where truth comes in degrees.